Hi guys, for our next video we're going to be talking about another physical process, which is dissolving and the heat that goes along with making a solutions, and then something called calorimetry, which is basically how you actually measure how much heat is involved in a process. So first let's talk about the heat of a solution, which is, you'll see over here, delta H, SOLN stands for solution, and delta H solution is defined as the heat changes that occur when a substance dissolves in water. So for example, when 1 mole of sodium hydroxide is dissolved in water, the solution becomes so hot that it can actually steam. So here's the process that is happening. When NaOH as a solid is dissolved in water, we get sodium ions and hydroxide ions. So when ionic things dissolve in water, the ions actually dissociate. They break apart and they become aqueous. For this particular solution making, 445.1 kilojoules of heat are released from this process when 1 mole of sodium hydroxide dissolves in water. So again, we can use our delta H of solution as our conversion factor. So we want to know how much heat is released when 50.0 grams of sodium hydroxide dissolves in water. So using dimensional analysis, 50.0 grams over 1. Because our heat of solution is per mole, we have to convert our grams to moles. So 1 mole of sodium hydroxide has a molar mass of 39.998 grams, and that comes from the periodic table. And then we use our heat of solution, 445.1 kilojoules per 1 mole of sodium hydroxide. So our grams cancel, our moles cancel, and we end up with a total of 556 kilojoules of heat released when that much sodium hydroxide dissolves in water, and that's a pretty significant amount of heat. Now we can also look at processes that absorb heat. So for this example, we want to know how many moles of ammonium nitrate must be dissolved in water so that 88.0 kilojoules of heat is released from the water. And if it's released from the water, that means it's going to be absorbed by the ammonium nitrate as it's dissolving. So is this an endothermic or exothermic process? Well, if the water is releasing heat and the water is the surroundings, then that means the system must be absorbing the heat, meaning that it is an endothermic process. And we also know that because the delta H is a positive value. So for our example, we'll take our 88.0 kilojoules that we want over 1, and then again use our heat of a solution. 1 mole of ammonium nitrate will absorb 25.7 kilojoules. And when we divide, we get 3.42 moles of ammonium nitrate. And again, that would be an endothermic process. So when solutions are made, they can either release heat and the solution becomes hot, or they could absorb heat and the solution becomes cold, because again, water would be considered the surroundings in this case. Okay, so let's talk about how we measure heat change using something called calorimetry. Calorimetry is the accurate and precise measurement of heat changes for chemical and physical processes. All right, so here's how calorimetry works. The idea is that the heat absorbed by the system is released by the surroundings, or vice versa. And we do the whatever the process is in an insulated container called a calorimeter. Now usually we'll use styrofoam coffee cups. They're very insulating, they are a good size, they work really well for cheap calorimeters for the labs that we'll do. Now when you're doing calorimetry, generally water is going to be the surroundings, which means the heat of the system is equal to the negative heat of the water. So if we can calculate the heat of water, then we know the heat of the system itself. So we're going to use delta H equals Cm delta T to calculate the heat of the water, which means we need to measure two things. We need to measure the mass or the volume of the water that we're using, and we need to measure the initial and the final temperature of the water so that we can calculate the delta H. Okay, so here are what calorimeters look like. Again, styrofoam coffee cups work really well, so you can see here 2 of them are nestled together. Water is in the coffee cup. There's a thermometer. It has a lid to try to keep as much heat in as possible and not lose it to the air. So there would be some sort of reaction occurring in solution. Over here, again, coffee cup, thermometer, lid. This time we would put something hot into the water, and as the piece of metal releases heat, the water is going to absorb it, and we could measure that change in temperature and calculate heat that way. So that's kind of how a calorimeter gets set up. Okay, so let's work out an example. A small pebble is heated and placed in a foam cup calorimeter containing 25 milliliters of water at 25 degrees Celsius. The water reaches a maximum temperature of 26.4 degrees Celsius. How many joules of heat were released by the pebble? Okay, so here's what we know. In this case, the question is asking us to find the delta H for the pebble. And we know that the law of conservation of mass says however much heat is released by the pebble, meaning this is going to be negative, will be equal to the amount of heat that's absorbed by the water. And we can calculate the heat that's absorbed by the water. So to do that, we're going to use Cm delta T. So that means we need to know the specific heat of water, which is 4.18 joules per gram degree Celsius. We need to know the mass of the water. Now, up here it tells us the volume, but we know that water has a density of 1 gram per milliliter. So 25 milliliters will have a mass of 25 grams. And then we need the change in temperature of the water. So final minus initial, 26.4 minus 25.0 is 1.4 degrees Celsius for our change in temperature. So when we calculate all of those things, we get a grand total of 146.3 joules. Okay, so that means the water absorbed 146.3 joules. So how much heat did the pebble release? Well, if the water absorbed that much, where did it come from? It came from the pebble. So the pebble released negative 146.3 joules. So when you're doing calorimetry, you have to remember that however much heat the water absorbs comes from the system. Or if the water got colder, that means the system is absorbing the heat that the water is giving off. So that's what you do to calculate the amount of heat in a particular system using calorimetry.